Hey, hi everyone. Very good evening. Hi, Supriya. Good evening. Hi, Anand. Hi, Srisha. Good evening. Great. So, is my voice is clear to you all online? Thanks confirming. Hi, Harsh. Is my voice is loud and clear to everybody? Hi, Venkatesh. Yes. Wonderful. Hi, Sush. Great. So, let us get started. So, what are the topics we have covered yesterday? What are the topics we have covered yesterday? Optimizes. We discussed about optimizes. Activation functions. Yes, Rishikesh. So add and meta delta take gradient descent. Yes. And have you all gone through the material that I have attached in your dashboard? Have you all gone through the material? All right. Harsh, Supriya, Buran. All right. Perfect. So let us get into today's session. So today we are going to get into the scripting part. So in the last sessions, what we have done is nothing but we started with the deep learning, and 2 days we spent time to understand the basics of the foundation theory of this deep learning neural networks. So now we are going to get into the scripting part of neural network, and we are going to understand how exactly we are going to combine optimizers, um, different activation functions, how we are going to write it here. That's what we will be taking it today. All right. So let me share my screen. Everyone, you can open up a new Jupyter notebook. New Jupyter notebook, you can just open it up. All right, let me share my screen. So what I'll do, so I'm just going to get into a folder where is EDL program. So here I'm just going to create a new folder first, new folder. And let me name this folder as deep learning. And within this folder, new Python 3 file, let me create it. All right. So here I'm just going to give a nickname, not a nickname. This is the data set what we're going to work on. MNIST digit classification between 0 to 9. All right. Basically, there is one. Has anyone heard about MNIST dataset before? MNIST dataset? Yes or no? Anyone heard about this dataset? Okay. No, that's what I'm getting it. All right, no issue. So this is just for understanding purpose. What you can do, it's an internet taken data set. So just give MNIST data set. All right, let me just get into the internet. Great, this engine. So now, what is this MNIST data set? I'm asking this Google. So it is saying the MNIST data set is an acronym that stands for the Modified National Institute of Standards and Technology dataset. It is a data set of 60,000 small squared 28 by 28 pixel, that is grayscale images of handwritten single digits between 0 to 9. Very clear. So let me copy this. Maybe you can also copy. Let me copy. And I'm just coming back here. Just giving a nickname. About dataset. Let me paste it. I wanted to make it bold, so let me make it bold. No plastics. So about dataset, MNIST is a dataset. Let me rename it MNIST. You can also work along with me. MNIST is a dataset of 60,000 small squared 28 by 28 pixel grayscale images. Grayscale is nothing but black and white images of handwritten single digits between 0 to 9. That is, let me click on these images. So if you see, basically the data from various, because various people has been collected. For example, if I'm just asking, hey, Lakshmi, can you just give me how exactly you write 0? I'm just getting it from Aditi. Let's say, and I'm just asking from Renuka, can you just give me how exactly you write 0? I got it. Maybe Bushra Patan, got it. So I've got this totally 0 in different formats, because someone will write 0 like this, will write 0 like this. So in this way, the different images, it's a kind of single kind images has been captured. We know that image is nothing but what? It is a combination of pixels. So one image is a pixel of, see this image is a pixel of 28 by 28. Length is 28 and width is 28. So 28 pixel I'm having towards left to right and top to bottom, 28 by 28. Now it is a black and white images. Black and white is also called as grayscale images. So in this way, in trained data set, for training purpose, we have 60,000 images. All right. And for test purpose, because that data set should test purpose is nothing but what? So that data, it shouldn't be seen by the during the training time. So, but it will be very similar, but it won't be seen. It might have seen or it might have not be seen. So that's what the point. So this data set is something what we're going to work on. All right. Now, from where we are going to take this particular data set is nothing but from Keras library itself, we do have it. And one more point to be noted, in case if you're working with this image related and image related applications, the one one library which you have to install is nothing but Keras and TensorFlow, we can say. Now, take Keras and TensorFlows, in case if it is not installed, you can check it like this. You can just give a pip command, pip install TensorFlow. Just try this. I'm just giving shift enter, pip install TensorFlow, and also you have to install pip install Keras. For me, it is saying requirement already satisfied. All right. Now, what you can do, you can just install only this particular TensorFlow, because earlier TensorFlow and Keras was separated, means it was two separate libraries. Now what they have done is nothing but Keras is a high level library where the TensorFlow has already occupied it, means they have already taken this Keras. Because executing this TensorFlow is pretty difficult. You can again, what you can do, there is an official website for tensorflow.org. Just get into this particular website. And here if you see API, let me click on it. See this for mobile and edge application for production and how to use it and everything. You can just take a read on this particular part later. I think Umesh, by mistake, you turn on your video. Let me stop it. So here, if you see resources, sorry, API, let me click on versions. So here, if you see TensorFlow 2, we are at TensorFlow 2, 2.8 is the current version. Now, if you scroll down, these versions started from TensorFlow 1.0, 1.1, 1.5. In this way, they are just releasing continuously. And community supportable languages are Scala, Rust, Ruby, R, Julia, C Sharp, Haskell. So these are all the different TensorFlow supportable languages. Supportable languages. Yes, and it's also used for Python also. Basically, this TensorFlow has been constructed with C++ library, C++ language. Now, to directly implement TensorFlow, it is going to be a bit difficult process. So for that reason, we are relying on a high-level library, which is going to smoothen our process. All right. So for that reason, I'm just importing Keras also here. But earlier time we have to separately install TensorFlow and Keras, but now TensorFlow, if you're installing TensorFlow, that's sufficient. All right, that will install this Keras. And if you're finding this kind of asterisk button here, it will this Kera TensorFlow itself a 560 MB file, I think so, 560 or 450 something. It will take some time based on your internet speed. Okay, once it is done, what you can do, you can interrupt the kernel. All right, because post installation you can interrupt the kernel, and then you can just restart it. Okay, interrupt and restart it. Right, now let me delete it. So now for me TensorFlow got installed. So now what I'm doing, let's say I just want the after installation, we have to import TensorFlow into our Jupyter notebook. So what I'm doing, import TensorFlow as TF. All right, TensorFlow as TF, I'm just giving it. Let me see. I just wanted to check how exactly whether it is getting imported or not. All right, now if you say TF dot double underscore, or we can say TF dot tab button, you will be seeing a lot of things. All right, a lot of things. Now I just wanted to check out the version of it. Let me scroll down. I'm not having this double underscore. This double underscore, I'm just giving it to check what version it got installed here. It is 2.7. Basically, I am at this particular version 2.7. So it again depends. All right. Now, as I said before, we are not directly going to work on this TensorFlow version because it's going to be pretty difficult to write the scripts. So for that reason, what I'm doing from TensorFlow, I'm going to import. Let me give a tab button. Keras. See this? Keras. You don't need to install separately, as I said. So TensorFlow, one library is something fine because within TensorFlow, we are having Keras. Now I want Keras. Now we don't need this particular TensorFlow. So if you want, you can just keep it. And also if you see Keras dot double underscore version, this is 2.7.0. So we don't need this TensorFlow here. We just need this particular Keras itself. That's what we needed. So I'm just deleting it. Let's try to, Keras is something which is going to smoothen our process. 1 minute. All right. Now Keras has been imported. Now I just wanted my data set to be here. So for that reason, what I'm doing, from where exactly I can take the data set, visit your Keras website, keras.io. Here you're having get started, click on get started. Then here, if you scroll down, Keras API references. Within this Keras API references, you're having built-in small data sets. Okay, let me click on it. MNIST digit classification dataset. So let me again click on it. So here, these are all some data sets for practicing purpose available within Keras. We are having these data sets for practice. Even within machine learning, there is a library called a Seaborn. We are having some data sets which is available in C1. We are having another library called ExcelR. Within that library, we are having some other data sets for practicing purpose. Now what I'm doing, MNIST digit classification data set, let me click on it. Now I just wanted to load this particular data set. How to load it? So this is the script. And also this one says, this is a data set of 60,200 28 by 28 grayscale images of the 10 digits along with a test set of 10,000 images. So more info can be found by this particular page. And what it is going to return? Tuple of numpy arrays. So since it is a tuple, I'm just enclosing with parentheses, x train comma y train. This is how we have to take it. All right, that's how we need to take it. So what I'm doing, let me copy this, let me paste it. Even TF is still not required because keras, from keras we can do is equal to this. I have to capture in this particular thing. This name can be interchanged. This name can be changed. So see this. So let me give a name like X train here, Y train, and X test and Y test. That thing I did, I just simply copied and pasted it. Now here, load path is nothing, but it is going to take it from the internet itself. Let me load it. Shift enter, I'm just giving it. So here, the data set has been loaded and stored over here. Now, this is what the very first step. All right, whenever you're working, step number one is nothing but import necessary libraries. Okay, then the next step is nothing but second step number two, import data set. That is going to be step number two. So business understanding, data collection, and then data understanding. Third step is data understanding. So in data understanding, the initial analysis we do. So xtrain dot, if we give shape. So it says 60,000 images of size 28 by 28. And also you can just give it y train dot shape. It says 60,000. So 60,000 comma. What does it mean? It is having it as an integers basically. So now I just wanted to say what is available in xtrain. So xtrain of let's say zeroth index. Zeroth index, what exactly it is available? I wanted to see. Now see this. It is just giving me 0, 0, 0, 0, 0, 0 and everything. Now what I wanted is nothing but actually it is a, and we know that the pixel values always range between 0 to 255. See this? Pixel value range. For grayscale images, the pixel value is a single number that represents the brightness of the pixel. The most common pixel format is a bytes image, where this number is stored as an 8-bit integer, giving a range of possible values from 0 to 255. Typically, 0 is to be taken as black and 255 is to be taken as white. Even we can just interchange it, but this is a given. So the one takeaway point here is nothing but the pixel values ranges between 0 to 255. Right. Now, in case if I'm just making it as a data frame format, I can get to know what number it is. All right. See this. Let me do one thing. Let me import pandas here. Pandas as PD. Anish, I'm unable to install TensorFlow. It shows could not find a version that satisfies this recommended TensorFlow. Do one thing, Anish, try getting into Colab. If I'm getting into fixing this error, it will take a lot of time. So later you can copy this and paste it in Stack Overflow. You can get this answer or some solution to fix it. Try to work the same script in Google Colab. It should work. Okay, that's a temporary fix for now. All right. Now, if you see, let me import this pandas as PD here. Now, PD dot. All right, PD dot data frame. If you give data frame within this, I just wanted to take it. All right. And here, if you see data is equal to none, it's been there. We can give it this data or directly also you can give it, that should work. Now, if you see, this is what it is just giving me dot, dot, dot. In case if I wanted to see all the columns, what do we need to do? Configuration. Let's say it's a trial data, or it's a data, or some input data. When I don't require this, but let me do one configuration and come back here. PD dot set underscore option. This is just for understanding purpose. I'm just making it. Yes. Now, if you see, I'm just making it a data frame format. What number it is? What number it is? What number it is? Only Harsh responded. Nobody could find any other number here. Anil 2 or 3, Supriya 5. Wonderful. See this? This is nothing but it is what is this? This is nothing but what? Handwritten digit 5. Right? So if you're connecting all those things, you will be getting a number 5. So this is something in a data frame format. I just made it to display this to you, but actually it is an image. Let's say this 28 by 28. 28 by 28 pixel, it is an image. Now I just wanted to see this as an image itself. How do I do that? If I wanted to see this as an image, what need to be done is nothing but for data visualization, which library we use? Data visualization. Seaborn Matplotlib, right? So let me use this particular Matplotlib here. From Matplotlib, let me import pyplot as PLT. All right, one visualization library which we use most commonly. So now what I'm doing, I'm just using PLT dot. Within this, there is something called as IMShow. IMShow is nothing but image show. All right, it is a function, so I'm using open and close parenthesis. Within this, X is nothing but what? Let me scroll down. Display data as an image on a two-dimensional rectangular raster. Okay, so this X should be like an array like. So what I'll do, so directly I'm just giving X string of which index? 0th index. Now see this, number 5, I got it. It's a 28 by 28 pixel, but still the color is something something different color. I'm just getting it. So what I'm doing here, I'm having something called as color map. CMap is nothing but color map. So I just wanted to display gray color, but are we having any clue here? So we just in a string we have to give it string, or we have to visit this particular thing to get what are all the colors available. We can do that later. All right, Matplotlib colors. See this, choosing color maps in Matplotlib. If you're reading this particular plot, you will be getting a good understanding about it. What are all the colors available and everything. But what I'm doing, since I've already done this research, so simply I'm just giving, hey, I want gray color. All right, gray color. Now I got it. Gray color. In case if you're making any spelling mistake, let's say GREY, it will throw you an error stating that, and it will give you all the list of color names. Gray is not valid for name. So these are all the different names that you can give it in this particular single string. All right. So now I made a mistake. Now I just want to get this gray color. So what is the right spelling? Gray. Let me copy it. Gray color. So it is nothing but what? So the X train, all the training is nothing, all the training data is nothing but your images. 0's image is nothing but 5, but it is an image. Now I wanted to tell my machine, hey, it is number 5 as an integer format. I have to give it. So if you look onto this particular Y train of this particular zeroth index, it is nothing but what? It is 5. Again, if you see any hundredth image, let's say thousand image you want to see, it is nothing but what? It is 0. So again, Y train of the thousandth index, it should be also 0. So in that way, I'm taking all the 60,000 images, I'm providing it, and I'm also saying, hey, if this is the image, this is number 0. In this way, I'm providing the question, and I also am providing the answer so that the network can learn it. So this is all about data understanding. Up to this, are you all clear? Once confirming, able to understand? All right. Only Anil, Harsh, Astosh, Roshikesh, Veera Makali. I think only these people understood. Others, maybe you can focus on it, or else if it is understandable, that's good. Let's continue this. So now we are looking into the data understanding. Okay, we got to understand how exactly the nature of the data set is all about. Now what we are doing again, the next step is we can go and build the model. All right, how exactly to build the model and everything, let's do it. But before that, before model building, the one step is nothing but fourth step is data preparation, or we can say data pre-processing, or we can say data preparation. All right. So here, what need to be prepared? So here, as of now, I'm not giving anything, but one point here that we can do is nothing but extrain. Dot. If you look onto the standard deviation, all right. So the standard deviation, it should be more or it should be less for better learning. What do you say? The standard deviation, it should be less or it should be more for better learning. Chaitanya, Harsh. Mhm. Right. So it should be less, right? So, but here, if you're just looking onto it, it is 78.56. It's pretty high. So even your text data, that is also 79.172. So here, if you see the standard deviation is pretty high, but there is a way to normalize this particular standard deviation, but I'm not doing that for now. Let's take this particular data and let's try to go with the same standard deviation and see how exactly the network is going to learn it. All right. So now, okay, so let me do a quick recap. So what I've done is nothing but importing the necessary libraries and then importing the data set, checking out the shapes, and then I just for the purpose of understanding, I just display this one index, zeroth index, that is one image in a tabular format, and we found that it is number 5. And then I just wanted to see it in an image format, so I just imported matplotlib here. I just imported matplotlib, and PLT, within PLT dot, I'm just having something called image show. Within that, I'm just providing, I just want 1000th index. What is that image I just wanted to see? And color map is equal to green. Gray color I wanted to see. So I'm just looking into this particular thing. It is gray color. And this is my question. 1000th index image is nothing but 0. And what is the answer for? In integer format, we are providing it. It's a kind of labels. For this image, this is 0. For this image, this is 5. This image, this is 9. In this way, we are going to teach submissions. But we just understood the data, how exact it is. Till now, we have understood. And in data preparation step, I was saying that there's a lot of the standard deviation should be less. If it is more, the learning won't happen well. as we have already learned it in the statistics session. That's what something I was explaining. Got it? All right, great. So now, fifth step is nothing but model building. Model building. So in model building, so we need this particular libraries, right? So from Keras, there are a few things which we want to build the model. From Keras, I'm importing something called as, see this, if you give a tab at a lot of things, you'll be getting it. I just want something called a sequential. Sequential is used to create a pipeline. To create a pipeline. And this is the starting point. Starting point to build the architecture. All right. So then also I want few layers. So from Keras, I just wanted one layer called as flatten. Flatten layer I just wanted. I'll explain what exactly flatten. Flatten. Then give a tab button, you'll be getting it. And then dense layer, sorry. From Keras dot, here you're having something called as layers. All right, layers I wanted. So what I'm doing, layers, import. I just wanted the flatten layer. Yes, flatten layer I have, comma. And also I just wanted to import dense layer. Yeah, dense layer I have. Yes. So two things I've done. Now, these are the necessary libraries to import it. Now what I'll do, let me give sequential. What exactly it is? Sequential groups a linear stack of layers into TensorFlow model. All right, this is a starting point, as I said. Now this is a model. Let me initialize this particular sequential package to model. All right, some any name we can give it. So I initialized. Now what we can do? Now model dot. You can just you can find a lot of things. So here what you can do, you can use something called as add. All right, add. Now within this add, you can see this adds layers instance on top of the layer stack. So you can add the layers one by one. So what layer first we have to add, it is nothing but firstly, I just wanted this particular flatten layer. Flatten layer. Why this particular flatten layer? We'll just understand this. Flattens the input. It does not affect the batch size. Okay. So here if you say arguments, and keyword argument is also available. Now here you can just give data format. As a string, you can give it. And the ordering of the dimensions as input, channel last, and see this, and example, how you have to give it model dot. Convert to, you can give it input shape. These are the things that you have it. Now what I want to do is nothing but, so here, since you're using this particular flatten layer, all right, so you just need to mention, I'm just copying this input shape first. All right, input underscore shape. Let me copy this. This coming back here, pasting it inside. All right, now what is the input shape of our data? Let me remove this. What is the input shape? It's nothing but 28, 28, 1. So this is my input shape. Now let me say model dot summary. All right, there is something called a summary. Let me click on summary, and then now let me see. Now see this. Now why I just mentioned 28 by 28 and what is this particular flatten? We want to understand this. So let me explain this particular part. See this. You're having one image. You're having one image. Let's say 5. It is nothing but what? 28 by 28 pixel, right? So in your neural network, or it artificial neural network, or we can say feed forward neural network, how many input layers you can have? This I have to give it to input layer, right? How many input layer I can have? How many input layers we can have? Srisha Hastoshi is 1. Yes, you're right. So I can have only one input layer, right? So I was just asking Harsh, in an artificial neural network, when we are building a neural network manually, or otherwise it is called as feed forward neural network, when we are building it, the question is how many input layers we can have? Only one. How many hidden layers we can have? How many hidden layers we can have? Many, right? So we can have n number of hidden layers. Let's say hidden layer one, two, three, four, some neurons, hidden layer two, something. And how many output layers they can have? Only one. Great. So here, if you look onto the input image dimension, what dimension it is? What is the dimension of input? It is it one dimensional input image? Two dimension, right? So how can you directly give to input layer now? If it's a big, we can take this lengthwise. If you're taking it, only you can give it to the input layer. So if you want, if you're having two layers of input layer, lengthwise pixels I can give it here, breadthwise pixels I can give it here. It is not available. So right. So what we do is nothing but, so we take this particular 28 by 28 and we flatten it. Flatten is nothing but, what is the multiplication of 28 by 28? I think it is 784. So 784 neurons I wanted to create it. So this pixel value is whatever I get, I will be getting it here. All right. And this pixel values over here. This pixel values here. This pixel values over here. So each and every pixel values will be created as neuron. So because of that, how many neurons will be created in the input layer now? How many neurons will be created in the input layer? 784. All right. 784 neurons will be created here. If it is 784 neurons, maybe the second hidden layer, it can be a bit less compared to this. Maybe I can say 150, or we can say 50. This the second hidden layer can be 30. That way, it will keep reducing. Okay, number of neurons will keep reducing, and again, selecting this particular numbers is like a trial and error. But one point to be noted is nothing but, in case if we're having 784 neurons, obviously it will need to be reduced. All right, so that's what the point over here. All right, now let me come back here. So because of that, when I just give model.summary, or this model.summary, what exactly it will do? Shift repeat, I'm giving it. Prints a string summary of the network. How exactly the network I'm just building it, it is going to give it to me. So first itself, my input image is going to come, my input image, if it is coming in, I'm going to flatten it so that it is going to convert it into one dimension. Now after converting to one dimension, model.add, I'm going to add this particular dense layer. All right, let me add this dense layer. Since it's a layer, I'm just giving function within this, just your regularly densely connected in a neural network layer. So now if you can just take a read on it. Now if you see what are the arguments, units is nothing but number of positive integer, that is how many neurons you wanted to have. So let me say units is equal to, let me keep maybe 150 units, comma, activation. What activation function we have to have? You can just mention the name here. All right, activation function is equal to, let's say I want to use reload activation function. So again, is this R need to be capital or small, because Python is case sensitive. If you give it wrongly, it is going to throw me an error. Here I'm not having anything like this. So how this need to be given? Again, Keras documentation is the key. Now here, if you give Keras API reference, click on this layers API. Now let's see this. Now we got a clue. Activation is equal to, this is how you have to use relay activation function. If you scroll down, all the layers, you can just study it one by one. This is a very good documentation to study. See this relay activation function, sigmoid, software, stanage. Let's click on relay activation function. Okay, in case if you wanted to use it, you can use it in this way, or what you can do, or you can just give activation is equal to reload. All right. In case if you wanted to use any other functions, sigmoid, in place of that, you can just give sigmoid. So SSS should be small. Softmax, S should be small. So in that way, this Keras, if your documentation, if you're reading it, will be giving you good understanding. Now we got to understand that if I want to use reload, this is how I have to use it. Now we got an understanding about it. So I'm just giving reload over here. right? Now, in case if you wanted to add second hidden network, you can copy this. You can add it over here again. And the second network, you can just give a layer like reducer 50. All right. But let me look on the summary, model or summary. So 784 neurons will get connected to 150 neurons, and that 150 neurons will again connected to 50 neurons. Okay, two hidden layers I have. Now one more again dense layer I'm creating it, but here I'm just going to give how many output neurons I have to create it. That depends on the number of outputs we have. All right. So, and one more thing, what activation function I have to choose for multi-class classification? Which activation function I have to choose for multi-class classification? Which activation function to choose for multi-class classification? Rishikesh, perfect. Good observation, Rishikesh. I think only Rishikesh observed the session. So as I said before, the math of softmax is nothing but e to the power of x divided by summation of all the other networks, right? So in case for multi-class classification problem, we have to use softmax activation function because of the mathematical equation it has. Just scroll down and read about the softmax activation function, where exactly it takes exponential of e to the power of x divided by summation of e to the power of let's x1 x2 x3. So basically what will happen is nothing but, so how many here I'm just going to give soft max, and how I'm just giving it spelling and everything. I got it here, soft max I got an understanding. So with that I'm just giving it, it's everything is case sensitive. And how many neurons I have to create in the output layer? It is nothing but 10, because it is 0 to 9 classification. So when I'm constructing the network manually at my output layer, I'm having n number of hidden layers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me take 10. So this neuron is for 0, this neuron is for 1, this neuron is for 2, this neuron is for 3, 4, 5, 6, 7, 8, 9. So since it is starting from 0, the total number is 10 neuron I've created. Why softmax? Softmax equation is e to the power of x divided by summation of e to the power of xi. That is, what is the probability of this particular neuron? If this probability, if it is higher, then this probability, this neuron will get triggered. Only this neuron will be triggered. If the probability, let's say one image I'm just giving it, let's say the number is 3. After learning it, this neuron need to be triggered. Only this neuron. So the maximum probability neuron will need to be triggered. For that, we try to use softmax activation function, so that it is going to give you the maximum pixel, maximum value out of all the neurons, and it is going to display to you. Okay, so that's the reason I just given it. And for binary classification, which activation function can be used? Softmax also can be used if you're using 2 neurons. But for I mentioned this yesterday. But for binary classification, which activation function can be used? Sigmoid. I think this point everyone observed. Wonderful. Sigmoid. So this is how I can construct my model architecture. All right, step by step, you can just add it. So now if you see, so 784 neurons got connected to 150, and this 150 got connected to 50 and 100. So this number is nothing but an internal parameter calculation, weights and bias calculations, which can be looked into it. Maybe if you're entered into a program, I can explain more about it. What is this parameters, how it is getting done and everything. But now let's stick with this. So this input layer is getting flattened, and it is getting connected to 150 neurons. And this 150 neurons is going to get connected to the second layer, hidden layer, with 50 neurons, and that 50 neurons with 10. Now for simplicity, I need to train my model a bit faster. So I'm just hiding this. I don't want this particular second hidden layer. I'm input layer, one input layer, one hidden layer, and one output layer, just for simple calculations I wanted. So the one point to be noted is nothing but model building is a two-step approach. Okay, the first step is nothing but step number 1. I can say build your architecture. build your architecture. All right. After building your architecture, you have to compile it. Still, I have not provided my input and output. First, in model building, build your architecture. Step number 2, 5.2, compile your architecture. Compile your network or architecture, anything is fine. All right. Now, what do I do is nothing but model. See this, since you stored everything here, model dot, there is something called as compile. Okay. So within this compile, you have to choose your optimizers, loss functions, and also metrics. If you want, you can just copy it. Now let me see. So which optimizer you want, whether you see this, that's what I said. The default optimizer, it would be nothing but RMS block. In case if you wanted to choose it like Adam, just scroll down. Let's say it is an optimizer set. Let me click on optimizers. Scroll down. Let's say I wanted to use Adam as an optimizer. Adam here. So here, this is how I need to use it. Okay, just this particular name is sufficient. Let me come back. Let me use Adam. And which loss function we want? It is a classification problem statement. If it is a classification problem statement, let me come back, losses and probabilistic losses. We have to choose probabilistic losses for classification problem statement. Is it a binary problem? No. 0 or 1? Are we choosing between 0 or 1? No. So we are choosing between 0 to 9, multi-class classification. So if that's the case, categorical cross entropy, can I use it? Uses cross entropy loss when there are 2 or more label classes. Yes, we have it. We expect labels to be provided in one hot encoder representation. If you provide labels as integer, please use sparse categorical entropy. So now my label is in integers, right? Because 1, 2, 3, 4, 5, that's how my labels are. So we have to use sparse categorical entropy. One hot encoding is nothing but we have to have our data in this particular format, that is that 0th index, extrain 0th index. If I'm saying it, I'm having an image. Let's say that image is 5. All right. And output column I have to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In that way, I need to have it. This is one hot encoding. Just try to read about it. I'm not speaking more about it. There's a separate class for it. If in machine learning session, read about it. But here, my output is in integers, right? How I'm saying it is in integers? If you say y train of 5th image 2, it is nothing but what? It is integer. For 500th image 3. So your output is of integer format. Okay. So because of that reason, if it is integer, if you want to provide labels as integer, please use sparse categorical entropy. Now let me scroll down. Sparse categorical entropy. How to use it? Sparse categorical entropy. Let me copy. And you can also take a read on it. All right, sparse categorical entropy, how exactly it would work. So let me copy this, sparse underscore categorical underscore cross entropy. Let me come back here. Let me paste it. Within single quotes, we have to paste it. All right, metrics is nothing but whether we wanted to focus on accuracy or what exactly. Let me click on this metrics here. See this, a metric is a function that used to judge the performance of the model. In case if you wanted to know how exactly the model is performing, metric functions are similar to loss functions. See this, very similar to loss functions, except that the results from evaluating a metric are not used when training the model. So note that you may use loss functions as a metric. So loss function is sufficient, but in case if you want to use metric, you can use it, but except that the results from evaluating a metric are not used when training the model. Now accuracy metric, right? Because we are having accuracies. Let me click on accuracy metric. Let me just simply take this accuracy. Let me paste it here. Right. Model.compile. Let me execute it. All right. Now, still we are in model building process. We have not provided my training data or the test data. All right. So model building, as I said, it is two-step process. Build your architecture and compile your architecture. Now my architecture is completely ready. Got compiled and everything. Now we just need to supply my data. So the next step is nothing but model training. Step number 6. Model training. So in model training, what we do? Model dot, if you see, there is something called as fit. This fit is used to train my particular model. So within this, you need to provide X, Y, batch size, epochs. Let me copy. epochs, and anything else we have shuffle is equal to true, and validation steps we have validation data. If you have it, you can just provide it like validation data. Mm. In case if you have it, you can just provide it validation data and everything. So we can take it. Let's provide it validation data. All right. Now, okay, we just copied few parameters which is available inside this fit function, but how to give the values inside it? Again, read this particular documentation carefully. Now let me scroll down. X, it is nothing but the input data. It could be NumPy array. We can just give like this, or TensorFlow tensor. Dictionary mapping inputs names to this. That can be given. Or see this, a tuple of, sorry, a NumPy array. We are having an NumPy array, right? Or a list of arrays. In this case, has model inputs. So this input comma targets. In this way also, any one of the formats, it should be fine. So now we are having inputs. Where exactly we are having the inputs? In xtrain. Let me give xtrain. All right. So for this xtrain, where we are, y is nothing but output. You can take a read on it. Y is nothing but y train. So how exactly y need to be? Y need to be? It could be either of NumPy array or a TensorFlow tensors. It should be consistent with respect to x. All right. So now what I'm doing? Where exactly my output is available? Y underscore train. All right. Now batch size. Batch is nothing but 60,000 images. If it is taking in, see this. Let's take a read on it. Keep my cursor here. Batch size. Integer. We have to specify an integer. If it is none, numbers of samples per gradient update. So as I said before, mini batch gradient descent it is. So you're having 60,000 images. You can't take 60,000 images at once and train your network. That's not possible. So you take some set of samples, you forward propagate, and you compute the loss and back propagate by updating the parameters. And then again, you take the second set of batches. So for like that, how many times you have to go? So if unspecified, batch size will be default to 32. All right. So do not specify the batches if your data is in the form of data sets. So let's say default is 32, right? Let me just give this particular 32 number itself. You will understand it in a while. Epochs. Epochs is nothing but how many iterations that we have to do. So in that way, slowly we have to read about all these things and we have to get a good grip on it. Epoch is nothing but epoch is an iteration over the entire X and Y data provided. So let's say I just wanted to go for maybe 20 epochs. And validation data is nothing but our data on which to evaluate. We are having an evaluation data that is nothing but X test and Y test, where we are having the training images and test images and the test outputs we have. Again, how to give it? Just give a comma. Just give a shift triple tap or something. You will be getting this. Now let me give how exactly validation data need to be provided. Validation data on which to evaluate. One point to be noted, data on which to evaluate the loss and any other model metrics at the end of each and every epoch. So at the end of each and every epoch, I will be calculating the loss and metrics because in the compilation process, you mentioned, hey, I just wanted to look into the loss and also metrics. So for each and every end of every epoch, you will be getting to know about this loss and also the metrics. That is the accuracy. So the model will not be trained on this data. Very, very important point. So if you provide this validation data, it will not be trained on the validation data set. It is just used for the validation purpose. See this, thus note the fact that validation loss of the data provided using validation split or validation data is not affected by regression layer like noise or dropout. Right. Now how to give it? A tuple. Tuple is nothing but what a parenthesis. So this way we can just give it. Let me copy this. Let me paste it here. And what is our validation data? Our validation data is nothing but what? X test comma Y test. Let me copy this. Let me come back. Let me paste it. All right. Now this particular process, let me just store it into something like training. All right. Let me store it into something like model training. Model underscore training. Let me execute it. See this. Now training is happening. Okay. See this loss I have and accuracy I have. And once the training is done, it is going to get applied for the new set data set. So 51% is the validation loss. Accuracy is nothing but 88%. And second epoch is nothing but, see this, after fourth iteration is performing, post that with respect to that accuracy, it is going to perform for the validation data. Let me interrupt it. In case if you don't provide, let me interrupt it. In case if you don't provide this validation data, you won't get this particular validation loss and validation accuracy. This. Yes, you won't be getting this validation loss and validation accuracy. So in case if you're having a validation data set, you can just directly give it. Anyway, it is not going to impact your model learning. Okay. So now let me interrupt it. I wanted to give this particular part. So let me include it and let me train my model. Let's wait for a minute. So let's just get trained. Meanwhile, we'll just understand what is this 187, 1875 by 1875. What is this? I'm not clear because here I just given 20 iterations and 20 iterations. But here, what is this? Anyone? What is this 1875? What is this 1875? Any idea? What is 1875? All right, no response. Fine. So let me try to help you there. So what I'll do, see this, let me open my calculator. Okay. Now, what is your training image size? What is your training data image size? Great, Harsh. I think you got it. Training data size. Training data size it is 60,000, right? 60K, right? So 60,000 divided by how many batches you said? 32. So just give 32. 1875. So you have 1875 mini batches. So for every epoch, this one by one, this batch is going to get into my network. So that's the reason you're getting 1875 over here. Got it? Batch by batch, I'm just sending my network. Able to understand this? All right. Even by default, even if you're not passing any batch size, by default, it is going to take 32 because we can't send entire 60,000 images at once. Okay. That's the point. Okay. Now the training is done. Now, if you see this particular part, the loss we are expecting to be 0, but see this. What is the use of validation data? Just to, I think I've already explained that, Harsh. Two times I've explained. So validation data just to validate. So here it is getting trained at the end of each and every epoch. In case how exactly it got learned. So now what I'm doing, let's say you got trained for machine learning. Now we are going and giving an interview. How exactly this would go. Now with respect to 1 or 2 sessions, even this EDL session, you're thinking that this is more than sufficient. You're going and giving an interview. Now interviewer is trying to ask you some other questions which you haven't learned in this EDL program. Then what you do, hey, I have not learned well. You come back, again, you're going to learn it. So this is same like this. So my model got trained. But when I'm providing a new data set from this X-test and Y-test, how exactly its performance? Because this data set is not seen by my model, X-test and Y-test. Only it has seen X-train and Y-train. So now when I'm providing, at the end of each and every epoch, when I'm providing a new data set, how exactly it is going to perform? So that score, I'm just looking into this particular part, validation data. So you can just take a read on it, shift triple tap if you give it. Validation data, in case in future, anytime if you get it, shift triple tap is the key. Read this documentation, data on which to evaluate the loss on any model metrics at the end of each epoch. Note that the model will not be trained on this data set. It is not going to be affected by by any layers like noise or dropout. Got my point? Perfect. All right. Now let's observe this particular part. Great, Rishikesh. Now here my validation loss, everything is there. All right. Now what I'm doing, I just wanted to plot it and see how exactly the network has learned its performance and everything. I just wanted to evaluate and also wanted to plot it. So what I'm doing is nothing but let me go for the next step is after model Testing, the next step is nothing but, I think step number 7, model evaluation. What we can do, we can say model dot, there is something called as evaluate. All right. Within this, you can give X and Y. Directly, you can give X and Y. Let me copy and paste it. What is your evaluation data? Evaluation data is X test. What is your evaluation output? Y test. All right. Now I just wanted to give it to my model. Okay, so the first one is nothing but, it is nothing but the loss. Okay, this is returning the loss. Loss is 40% and the accuracy is 94%. How exact it can be? Totally a different factor. So definitely it will never work. But again, we have to check it and see how exactly the model is learning. So let's do one thing. 8th one, model, we can say prediction maybe. Let me make a prediction. That is, so what I'll do is nothing but within this model, where exactly it is holding all the intelligence, I'm having one function called predict. Within this, let me provide all the text data, all the new inputs. So now all this text data, it is going to make a prediction, 0 or 1 or whatever it is going to make a prediction. So let me store all these results in something called as y predicted. Okay, I've just stored it over here. Now what I'll do is nothing but, if you want, you can just take a look at it. So PD within data frame format, we can just take a look at this Y prediction. See this 10,000 images, all those 10,000 images, 10 columns. I got it. Since you created 10, because 10 neurons you're having in the output layer, right? So here, the first image, which is the maximum pixel, this one, right? Okay. Which one is holding the maximum number? I think this one, 7. So which means that the 0th index is nothing but this image, 0th image, which is available in X test 0, it should be 7. Let's check it out. X test of 7. Here I got it, but I wanted to see it in an image format because test data holds this image. I am sure. Let me take it and color map is equal to gray. Okay, it is actually 9. What is the actual output? Y test of 7. It says it is 9. Sorry, 0th index, right? Y test of 0th index, it is number 7. See this? That's what here, if you see, number 7 takes the higher number. Okay. And 0th index, it is number 7. Maybe any other row. This everything is nothing but answer. For 10,000 images, what you got, since you created 10 neurons at the output layer, what is the probability of the 10 neurons? We got it here. Is this point understandable? Once confirm me. What data frame we have and what I'm saying, is it understandable or not? Analyze. Hush. Supriya, Stosh, perfect. Great. So now when I'm providing this 9997 index, what should be the image? What should be the number? What should be the number? My model is predicting what? This 9997th index image is what number? Is it 7? One check it. 2.37 e to the power of minus 26. What does it mean? 10 to the power of minus 26. So 26 times you have to take this point and place it here. So if you look onto this particular part, 1 e to the power of 0, which means that what? 100%. Got it? It is nothing but what? It is 3. Let me check it out. This particular image index, 9, 997. It is number 4. Actual output is 9997. It is number 4. Okay, so this is how my predictions it will be. But one point again, prediction is also done. That's okay. But let's look onto the model performance. Okay, how exactly model is going to perform. Let's try to understand that. So here, maybe this one we got to understand it. You can also do this. That's one prediction we'll do. That is, we can try to give this. That is, since instead of taking a look at this particular table, okay, which one is the maximum number and everything, you can also do one more task. That is, we can import something called as numpy as np, and within this numpy np dot, there is something called as argmax. All right. np dot argmax we have argmax. So within this argmax returns the indices of the maximum values along the axis. Now what I need to do, let's say this x test, when you're providing x test of 9997, this one, this will return me, what is it, 711? Sorry, y prediction basically. So since this particular one holds y prediction of 9997th index. So because y prediction holds the index, right? So it is saying it is number 4. So it's nothing but I just wanted to see which one, which index is taking the maximum number. So internally, this is how it is working. Fine. So now we got this in this table wise also you can check it out. Or if you wanted to check it out with respect to script by passing any one index, which number it is, you can use this particular part as well. Now, I just wanted to plot it and have a look onto it, how exactly model is performing. Now let me check at model performance. What is this particular model performance? I just wanted to understand. That is, here, I just wanted to plot between how exactly model got trained. So here I'm having PLT. Okay. Matplotlib I have not imported. So let me, Matplotlib I already imported. PLT dot, there is something called as directive plot. You can use it. Within this, plots y versus x. So plot x comma y. So now what is that x-axis that I wanted is nothing but. So here, if you see, since we have given this intelligence to model underscore training, now this model underscore training holds loss, accuracy, validation loss, validation accuracy. Let's see this. Model training dot tab button, if you see, epoch, history. In this way, it is having a lot of things. So within history, by using this particular history method, we can pick up your loss. Okay. After each and every iteration, what is the loss? We got it. And accuracy. You got this particular accuracy. So what I'm doing, I'm just wanted to plot this model underscore training by using this history. Let me take this particular loss in x-axis, and I wanted to plot this maybe this is my loss versus we can do, or right. So we can do this. So loss is something fine. If I'm plotting it, right, I got it. So what is there in x-axis? Nothing but x-axis speaks about epochs. Okay, it is speaking about epochs here, but here it is 1.5, 2.5 is giving it. So let me increase the size of it. PLT dot. How can I do it? Figure. Within that, we are having figure size, where we can increase the size of this so that I'll get the right numbers basically. Nothing but the width is 16, the height it's 10 maybe. 10 is too high. Let me give it maybe 6. Fine. Now if you're able to, now what is this x-axis? See, this 20 epochs. Now for 20 epochs, how exactly my loss is getting reduced? It is fluctuating more, up and down it is fluctuating. Let me, after plotting it, Let me give some labels to it. PLT dot X label. X label is nothing but epochs. Okay. And PLT dot Y label. Y label is nothing but it is loss. All right. This is nothing but my training loss. Okay. Training loss. And maybe I can give a title to it. Title is nothing but it is model performance between epochs versus loss. All right. Now, if I don't want to see this, let me just see plt.show. Let me give it. All right. Now I got this particular point. Great. So now model performance, if you want to increase the size is equal to, let me give 25. Yep. 1 minute. So now I got this. Now within this particular part, this is nothing but what? This is a training loss, right? How exactly training loss is happening. Why I'm saying training loss? Because you picked up loss. What about the validation loss? If you wanted to see this, plt dot plot. In one graph, if you wanted to plot this, two graphs, again, the same line itself, you can do it. Model history training dot history. You can pick up what about the validation loss, where it is getting stored. Validation loss is getting stored here at the end of each and every iteration. What is the validation score I wanted to see? Let me scroll down. Let me paste it. Now see this. Now validation loss. Okay, which color? I'm not sure about it. So which color takes what? Let me do this. So I just wanted to give a label here. So plt dot comma. Here label I don't have it, but after exploration I got to know that, see this Y label. Okay, label. Is there anything here? Basically, I just wanted to create a label like which color it is and everything. Let me say label is because I'm not able to differentiate which one is training and which one is test. I'm not able to see that. So what I'm doing, let me create a label. And this one, let me see. Let me take it as training loss. And here, comma, label, test loss. Okay, now let me see. Still, I'm not able to see this particular part. Why? Because we have to use something called as this label. If it need to get displayed, you have to use something called as plt.legend. plt.tab button, legend, legend. You have it. What exactly it is? Place a legend on the axis. Legend.labels. In this way also you can do that. But now if I'm executing it, okay. Now training loss and test loss, I got it. So this blue color is for training loss and orange color is for test loss. Now see how exactly test loss is increasing over the number of iterations. When iterations increases, my loss need to be decreased, right? But here it is increasing. So it is not something more efficient. Got my point, everyone? Why we are looking into the model performance? Why we are giving validation data? Is it clear? Able to understand? Wonderful, perfect. So now what I'm doing, so let me also, this is nothing but model performance of loss, training loss, epochs versus loss, right? Let me also have a check at this one. What is that? Accuracy. So what I'll do, accuracy, because history I'm having accuracy. Accuracy spelling is very important, and validation accuracy, right? Accuracy. The other one is val underscore accuracy. Very important. So let me also check it. Val underscore accuracy. And this is my training accuracy. Training accuracy. Test accuracy. Epochs and Y label is accuracy. Model performance between epochs versus accuracy. Now let me see. Look onto it. So blue color is my accuracy. For the training data, it is increasing. But see, for the test data, how much it is fluctuating? Lot. It's fluctuating a lot, right? So it need to increase. So how to improve model after checking performance, which is not up to the mark? That's what my point, Supriya. Just wait for a while. So here I've not done anything. If you have observed, I've just provided the same data, extend and widen. I just simply provided, even though the prediction is doing a better job. Actually, if I'm looking into the performance metrics, when I'm comparing my training data with my test data, it is not performing good. Are you getting my point? Right, Harsh, you got it. Are you all getting my point? Right, Jyoti. We are following one step-by-step methodology. Maybe you can follow up with the recordings. All right. Now, what I'm going to do, I'm just going to standardize it. All right. Let's optimize model performance. All right. Now, what I'm going to do, now again, I'm going to start from fourth step, I think. So data pre-processing. That's why this data pre-processing step is very much important. All right, there is a lot of things you can do to optimize your network. One step is by reducing your standard deviation. Okay, so now what I'm doing, let me copy all the cells, whatever I looked onto it. That is only this one, or else this standard deviation. Let me copy this, paste it, or what I'll do. Let me copy all the cells. So what I'm doing, I'm just clicking this cell and then I'm just giving the shift button and then down arrow, down arrow, down arrow. I'm just copying all the cells because I just wanted to change it and I just want to look onto it, right? And after selecting it, I'm just only clicking on this button C. C for copy all the selected cells. All right, now it is done. Now what I'm doing, let me click on escape button or somewhere. Now I'm selecting this particular cell. Now I'm just clicking on pressing V button. Now whatever the cells got copied, it will get pasted again. Now let me scroll up again. Where exactly I'm having, yeah, let's optimize this network. So this is what something we have done already. Now here I'm just creating a new line. So what I'm doing, this X train divided by 255. Now what I'm doing here, if you just look onto this particular part, so already I've, why divided by 255? Because the maximum pixel value is 255, right? So I'm taking all the values, each and every value, and dividing it by 255. If that's the case, all the values will get converted into float automatically. So, and also the values will range between 0 to 1 because the maximum pixel set is 255. And if the maximum pixel, if it is coming in 255 by 255, it is nothing but 1. So to make sure all the values will range between 0 to 1, and all the scales also, I'm just making it uniform so that the variance will be reduced. Now let me store it again into something called as, let me change it, X train normalized. All right, normalized. The similar way, X test also, let me do normalized is equal to my X test image divided by 255. I normalized it. Now what I'm doing, let me copy. Now let me check X train normalized dot standard deviation. Look onto it, it is 0.3. Earlier it is 78.56, now it is 0.3. Now X test normalized dot standard deviation, it is 31. All right, it is very low. Now if we follow this model method of model building, everything remains the same. I'm not touching this model because architecture is already built. We are not going to touch this particular part. Let me delete it. X. Fine. Compilation is also already done. Fine. In model training, okay. In model training, which input we have to provide it here? X train norm. And for validation also, which input? X train norm. Now let me train it. Now let me see. There are a lot of ways to optimize my model's performance. One of the performance is what we are learning here. Okay, let's wait for a while. So how many of you are finding it interesting or easy? Because in the last 2-3 days, we spent a good amount of time in understanding optimizers and everything. So here, with respect to script, as I said before, it is going to be a bit easier because just you have to give out the names here, which optimizer you want and everything. But knowing the theory behind all these foundations is pretty much important. So that's where we spend a good amount of time over there. So Priya, Rishikesh, interesting, fine. Even we will be working on a lot of other uh, files as well. You will get it. And okay. Okay, to the book. Since it is black and white images, it is getting trained fast. But next week, Monday, we will just get into one algorithm called as CNN algorithm, where exactly we will learn the theory. And then if you get into the scripting, but there is one drawback with respect to this. What is the drawback? Later, we will understand it. Let us wait for a few more minutes. Convolutional neural networks. We call it a CNN. Yeah, fine. Now this network learned it. So now what I'm doing, let me look onto the performance. See this, now the loss is 0, almost 0.003. Validation loss is also 0. Let me look onto. Earlier the loss is 40, accuracy is 94. How it can be? Now see this. Oops, loss is 26.46. Accuracy is 97. Again, this is not even. Again, we have to do some more steps also. So here, what you can do. Okay, this is something. Okay, this one for just for checking purpose. You can do it later. Model performance. Let me check it out. Now see, but it is efficient, right? Now, if you look onto it, training loss. It started from um, 35, and it is reducing. It is reducing, and test loss also. It is smoother compared to the previous case. If you see, earlier it was like more zigzagness, right? More zigzagness. But now from 18, it is getting reduced. It is getting reduced. So in this way, by optimizing, by using this, by normalizing this particular part, we we just slightly improved this model performance. Again, let's look at this particular accuracy. See this. My earlier, still I have not executed this. Before standardization, my test accuracy is fluctuating like anything, right? Actually, it need to increase. If it is starting from 94, it needs to increase slowly, gradually. Now, let me check it out. See this? Now it started from 95 and it is slowly increasing. Got my point, everyone? All right. Wonderful. So that's the end of today's session. All right. So the point here is nothing but we learned about 2 days. We spent a good time in understanding, yes, all the steps. Summary analysis given. Okay, let me copy and paste it here. Analyst given this. So summary of today's session. Worked on MNIST 60,000 pages, import data, data understanding, right? So now can you connect with the day 1 or 2 we discussed about life cycle of a data scientist. So can you connect with this? Even machine learning session also we looked onto the same thing. Deep learning also is following the same cycle. So can you relate with whatever we learned in today's session with day 1 or 2? Wonderful to danger. So Priya, Shiki, Sastosh. Yes. What is this? Anand? All right. Fine, you have taken a screenshot of that. Okay. Perfect. So any questions? Even the next, and one more thing. Before coming to this weekend, let me give you a task. So what task is nothing but I just want you to collect images of your friends. Okay, let's work on some real-time data sets. So reach out to 3 or 4 of your friends and try collecting multiple images. Your images should be of standalone. That is, one image should contain only one object. What does it mean? So let's say here I'm having Omkar and let's say Vaishali. Now Omkar need to collect only one image. So basically, let me explain in this way. So if you get into Google, let's say I just want, let's say, mm, maybe a dog. All right. Let me say maybe Vijay. After Vijay, we have Vijay. All right. I just wanted to collect only this person's image. Okay. Only this one image should contain only one object. So that we are going to work on image classification data set. So if you're just getting into this, so one image should not contain like this. All right. This is a two objects where exactly you're having 2 persons here. So if I'm giving to this, I can't say whether it is Vijay or whether it is actor Surya. I can't say this because 2 person here. So don't collect this kind of data sets anytime. So what you can do is nothing but collect one image should contain only one object. So in that way, try to collect as many images as possible from your friends. Let it be any dimension, but make sure when you're collecting the images, it should be JPEG format, JPG or JPEG format. Anything should be fine. Got my point, everyone? All right. And then what you can do after collecting it, just create any folder like this, CNN multi-class classification, any main folder you can create anywhere. And within this particular folder, create 3 folders or even 2 folders is fine. All right, let me relate it. Create 2 folders like test data, train images. Let the folder name also can be anything. All right, just make sure you're within train images, you're having, let's say I've created 5 folders. All right. Arjun, Kushbu, Mukesh, Shifali, Vijay. So within each and every folder, paste your files. If you're collecting Arjun images or your images, paste your files within this. Let's say if you're collecting Kushbu's image, paste Kushbu's image, only Kushbu's image, let it be 10 or 15. Image can be of any size or any dimension, not a problem. But collect as many images as possible. And then the same 5 set of folders you have to create within test data itself. All right, but the images what you have kept within train images, don't keep the same images. Try to give a new images in the test data, because training is, your model is going to see these names. Your model is going to look into all these images and it is going to understand, hey, this pattern is nothing but Arjun, and all this images pattern is nothing but Kushbu. And then it is going to get into Mukesh folder and it is going to learn, hey, this pattern is nothing but Mukesh. So in this way, your model going to get into each and every folder and it will collect all the images and it is going to map to the name which is mentioned in this train images folder. Now later what we do post training, now we take any one image from this test data, okay, Shifali or any image. When we provide this data to the network, now my network need to say whether this image belongs to Arjun, Kushbu, Mukesh, Shifali, or Vijay. So let's have a separate folders, but Just hope you all got what I'm saying. So training data, keep it a separate one. Test data, keep it in a separate folder. And then let's try to pass a new data to the new data to the machine, and let's see whether it is able to predict it right or wrong. Got my point? Another three different data sets of images, three different data, two different, three different data sets of images. I'm not understanding the question, Anil. So basically what I'm trying to say, just keep two different folders, train images, test images. Within that folder, train images, I can create as many folders as you want for multi-class classification. Maybe your friends, in case if you don't get any friends images, try to collect some images from the internet itself, but it should be in JPEG format. So it's a multi-class classification, but name your folder name correctly with whatever the label that you wanted to give it. That's it. Cartoon images will also do, yes, any images, Shruti. But try coming up with your own images, because instead of working with any any other dummy images or something, if you're working on our own images, it will be more interesting. Okay. So Chaitanya sir, in this way, police department is going to catch thief. Okay. Mm, yes, CNN algorithm is used behind most of the surveillance cameras for detection. CNN algorithm. Even your mobile phone is having the CNN algorithm, facial unlock features. From now onwards, we are going to get into the real-time use cases, how exactly it is working and everything. All right. Fine. So hope we had a good session today. So we just combined whatever we learned from day one of deep learning, and we matched it with respect to the scripting part. One task which I can give you is nothing but to try changing this. I think everybody, I will be sharing the script to the team. They will be updating it here. Just try changing this, maybe increase, you can increase the model performance by fine tuning your network also. That is, this is the architecture what you have built. Where is that? Yeah, so try reduce this particular number of neurons, and try keeping any other activation function, maybe tanh or any other activation functions. And yeah, so that you can do. And also here you can just try change your optimizers and metrics. You can try change it. Optimizers is something fine, or you can change it to AdaGrad or Adam and see how much time it is taking it. And see this, it is 5 seconds, 5 seconds and everything. But in case if you're going with gradient descent, it will take a long time. Okay, so just check out the time, which one is getting trained faster, and in that way try to compare it and come up with your study. Okay, that way you can understand whatever the optimizers that we know. Only Adam have used it, but try using other optimizers by getting into this website and click on optimizers. If you want to know how to make use of gradient descent, click on gradient descent. Okay, so this is what the gradient descent is. SGD is the name. Let me copy it. Let me come back. Let me paste it here. See this is stochastic normal gradient descent approach. So now normal gradient descent has been totally removed out. Why I'm saying it is totally removed out? Here you're giving stochastic gradient descent. Now automatically batch size, it will be what? It will be 32. So now it becomes what? Now it becomes what? Is it a gradient descent now? That becomes what? It becomes mini batch gradient descent, because you're using gradient descent, but since you're passing some batches in the training part, batch by batches, mini batch gradient descent. In case if I give batches equal to 1, then it becomes what? Stochastic gradient descent. That is picking one sample at once and updating my model performance. This will take a lot of time. Lot of time it will take. You can just try it out. Okay. Let me not. So in that way, try changing it. Try changing this networks whatever I given, and so that you would be understanding how to construct a better network and everything. Okay. Fine then. So let's be back by next Monday and learn about convolutional neural network architecture, and we can spend a good time over there. All right. Take care, everyone. Have a happy weekend. Let's meet next Monday. Hope you all learned new topics this week, complete week, Monday to Friday. Let's meet next Monday. Take care. Have a happy weekend. See you there.